All right, thank you. So this rule actually came about because we had some people talking in live coding and someone had to hold the microphone so they could speak, and that was obviously me. Luckily, I don't have to do this now. Yeah, thanks for joining me. The name of my talk is How to Build Imports Like a Pro with Symfony. I should put a question mark there, and hopefully at the very end we can actually talk and maybe you can tell me how to do that. In the meantime, I will just tell you what I usually do. And first of all, you already heard my name, Denis Brumann. You can find me on Twitter and GitHub and everything with my initial and then last name. And you can also email me with my full name at sensulabs.de because we are the German version. And yeah, so I'm in Berlin. I mostly do migration projects for clients. What that means is that they have software that is sometimes very old, sometimes not so old, but they're already quite unhappy with it for performance reasons, security, stability, stuff like that. And sometimes it's also old code. Very popular right now is Zen Framework 1 things because the PHP 7 support is kind of not there anymore. And so they move to Symfony, for example, and they get help, and that's sometimes me. And I just go in and try to improve the software as well as migrate to Symfony most of the time. So this is my day-to-day job. And since most of those projects are e-commerce projects, I tend to see kind of similar-ish things. And especially around the import and batch processing stuff, I see a lot of similar stuff. Unfortunately, due to NDAs and everything, I'm not allowed to show client code. So basically, I copied some client's import job, one of them, into rich text. Originally, I wanted to basically show all those single pages so you can get a feel of how long it is. Unfortunately, I didn't get to manage that, so you just have to use this kind of thing. Because the screen is very bright, you can't see it that well, but basically it's 44 pages long, and just the first page and the first bit of the second page is just the use statements. So it's not just all in one file, it's actually doing kind of OP. It has services and everything, but still it's huge. And the whole thing is like, I think 2,000 lines, just a command thing, which is not extreme, but still it's obviously not pretty. And I guess all of you will have these kinds of jobs somewhere around. I still write jobs like this. And one thing I wanted to basically set out in the talk at the very beginning is it's totally fine to have these jobs and even to still write these jobs and to start out your imports with stuff like that. Because if you actually look at what kind of imports you have in your system, you have a varying degree of how critical they are to you and how much things can go wrong. So this is just from Jenkins job. We have the cron jobs clustered in one folder and then live and stage system and test systems. So this is from the actual live system. And if you look at the second job, this thing ran a total of 3 times, and the last time it ran 2 years ago. So if I were going in and optimizing this kind of stuff, then probably the client will come to me like, what are you doing? You're wasting our time. We don't care about this thing. Sure, it takes 1 hour to run, but we don't run it that often, so we don't care. So any improvement you do on a one-off import job is basically wasting money and wasting your time. And since, especially if it's a huge job that's really nasty to look at, the minute you put it away, even if you wrote it yourself, then it's also not fun for you, so why do it? At the same time, you can have jobs that, even if they are very popular and run very often, like this one, 240,000 times. So it runs more than any other thing in the system, but it's super fast, it doesn't break, and it's convenient. So again, why waste time on improving this thing when it already does what it's supposed to do? The thing where you actually want to go in and improve your imports and your batch processing is when you have stuff like this. It runs moderately often. It maybe fails from time to time, so obviously there needs to be some improvement. And this thing just takes ages, 4 hours in this case. So yeah, this is something you might want to improve. Not always, but this is basically the gauge you can look at. And also you can look at how often, for example, the code changes. As a good example, I had a client project a while back where they had a subscription-based model. So basically every week, one set of cron jobs collected all the subscriptions that users had, checked if they were active, and then created orders from those subscriptions. Those orders were then basically preliminary to a certain date where they basically were fulfilled. And that meant that another cron job took those orders and created reports for the department that did all the purchasing and everything. At, I think it was 6:30 in the morning, they actually did the stuff, and if those imports weren't there by 7 in the morning, they were cranky, and usually the developers arrived at 9 to 10-ish. So, and obviously, even if you have monitoring, no one was looking at it at that time. So those things failed a few times, and people were not happy with it. So it can be crucial to actually know where to improve it. And those imports worked fine for a huge while, and everything was not a problem. So no one actually went into improving those. The thing is, it went downhill once we actually changed something about the subscription service itself, and those changes manifested themselves in the orders, in the way the processing works, and then later on things broke more often, and then it was problematic. So even if you don't set out to write good imports in the very beginning, which again you don't have to do, there should be some point where you basically revisit what you've done and check what you can do. And hopefully we can achieve something that basically all our import jobs profit from, that basically it will be more helpful. And the reality is that there is this nice quote from John Berkman that there's never enough time to do it right, but there's always enough time to do it again. This is basically what I always encounter in client projects, even if you write those nasty imports and if you have something that needs to be very urgent, at some point you will always have the time to do something new. You probably won't be able to salvage that thing. In some cases you actually can, but most of the time you actually get the time to do something again. And so what you can do is basically, based on the knowledge that you have from that existing job, you can actually write something that's more helpful now and more stable in the future, and then reusable. And this is what this talk is about. And we will start with looking at a very, very broad picture of what we can do to have a kind of architecture that will help us create really good jobs that we can use. And then I want to dive into some of the details of reading, which is one core part of most batch processes, then the actual processing itself, and at the very end, writing. So we will just go into each of these phases that basically every batch process has, and we look at very in-depth details of what we can do. So hopefully you have both a big concept that you can work with and start off as an architecture, as well as very on-point help that you can just implement even in your basic imports that you already have. And basically the architecture I'm describing is not my idea. It's something that comes from the Java world, the JSR 352, which is batch applications for Java. For those of you not familiar, this is basically what the PSR in PHP are built on. It's some kinds of specification across projects that promote a common best practice, basically. And if you're using Symfony, indirectly you already use some JSR stuff. For example, validation is actually based on the Java JSR for validation beans. And this is not something you will find in Symfony out of the box, but it's something that can guide you into some kind of architecture that you can build yourself, and that is basically proven to work in other contexts. And yeah, so the primary thing that we work with imports is the actual job itself and some steps that you do inside that job. And basically what this GSR specifies is that a job is made up of certain classes. In this case, I show you the job instance, the job parameters, and the job execution, and also the step execution. So there seems to be kind of a hierarchical order and some kind to add parameters to it. And then on top of that, for the jobs, you have a job operator and the job repository. And for the reading itself, for the steps, you have the item reader, the item writer, and the item processor. So you can already find the basic steps that I said we will always see in this architecture at a very low level on the step level. And above the job that describes what you're doing, there's another level, the job operator and the job repository. And it's super vague. I will show some graphics to make it a little bit more clear. Basically, if you follow this kind of architecture, what you have is a job that describes what you want to do, then the actual execution with all the parameters, like this is the job I'm trying to do right now with the current parameters, and then at the very end you have the job execution, like this is the stuff that's running, and then the job execution will provide step executions, and one job obviously can have multiple steps. So this is the way you drill down in this class structure, and each step is made up of a reader, a processor, and a writer. And basically this defines what this step is doing. And the reason why we have a job operator is this JSR also provides a way of running those jobs. Like the job operator will start a job, it can cancel a job, it can actually replay a job that maybe failed, and the job repository is what stores all those information about the jobs that we have, the executions that are planned, the actual instances that are running and their status. And even down to the step level, it will contain all those information so that you can represent it to users, for example, in your system. And because it's Java, obviously there's XML involved. This is basically how you describe jobs. This is a very basic structure. The job has an ID, then there's a step in there, and the step has readers with, in this case, a property, writers, and there's no processor in there, so it just reads something from one source and writes it to a different source. And there's actually a whole lot of more stuff in there, like you can have certain flows, you can have decisions to basically decide if you want to go to one step or to a different step, stuff like that. And there's also a lot of stuff on top there that we will basically kind of look into very later in the talk. This is basically what the model looks like, and the cool thing is that the logic that you write is basically only the yellow stuff. All the other stuff is provided for you in the infrastructure, or in our case, since there's not really an existing library for this, it's something that you probably write yourself once, and the idea is that those are kind of things that you rarely ever touch, and the closer it gets, the more likely it is that you might have to do changes. For example, with steps, you might want to have conditional steps and stuff like that. But with a very basic setup, you can just have job repository, job operator, some job that basically has descriptions like a name and some parameters in there that you want to use, and then you pass in steps. And it's actually quite easy to write something that looks kind of like the standard, and you have something like a job runner system that you can easily use. This is then what it looks like when you execute it. Basically, the job executes a step. Then this step will read from the item reader. You can see that there's no argument or anything in there. Basically, the item reader has an open and a close operation. So basically, you tell it, I want to open this file at this point, for example. The reason for this is that, so you actually kind of have a stateful service, but you have it for a good reason, that you probably have scenarios where you want to read from one file, but you want to partition it so that you have multiple steps that read the same input, but at different stages. So for example, the first 10,000 lines, the next, the next, the next. And yeah, so basically this is what the open close is there for in the item reader, and then you just read, and the read is just giving you back an item. In Java, it's an object. In PHP, it's probably more something like mixed, if you're being honest, or you have some container object, and then you process it, you get back an item. This can be a different item because in processing it can change, and then you actually read it again for as long as you want till you hit a certain batch interval, and then all those items that you have processed in this interval are passed into the item writer. This is actually quite useful. So usually when I started out writing my jobs, I had just the item reader, item processor, item writer, and then some command on top. And I basically had one item is read, one item is processed, one item is written. And what this does is basically that some information that you want to have in your writer encapsulated leaks out into the method that basically just pulls all those things together by basically having to be aware of transactions, for example. And by just passing in all those items, you can leave all those transactional information inside your writer, which completely makes sense, but initially I basically didn't come up with that, so that's already something that I found quite helpful. So just to give you a better idea of what this actually looks like if you have a job. So take, for example, we have our end of day job that has to run every day at the end of the day. We have certain parameters that you want to pass into that job to basically tell it that this is the job for this day. In this case, obviously the documentation is a little bit older, in 5 of May in 2007. This actually makes it our job instance. So the job instance is a class that comes from the description of our job that contains all those parameters. And then the job execution is the first attempt at running this job. The reason we have this basically separation is that this job can fail, and then you want to rerun this job, but it still stays this job for the fifth. It's not the job for the next day or anything. That's a separate job. So you have the separation, and it allows you to see that this one failed and the next one worked, and you have basically a logical separation there. And if you think about what you saw in Jenkins, you kind of have on a higher level something like that as well in Jenkins, where it lists you all the jobs that are available, and then you see the last success and last failure, which is basically the last job instance that ran. You can actually even have this play button with run with parameters, which is just basically taking this job profile and adding the parameters there to create an instance. And then at the very end, what you see in the log is basically the job instance, the thing that's running. So even if you don't actually implement this in PHP, you kind of find this variation of thing in other job execution platforms, like, for example, Jenkins. And yeah, when you add in the step, it basically is another description, and then at the end you have the job execution, the step execution that actually runs this thing. So this is basically a high-level concept of how you can architect the thing, which doesn't show any PHP code or anything. What I will go down is more in detail into is the item reader, item processor, and item writer, and not specifically as those classes, but actually what is happening in there and what you have to look out in there. So I'm not actually showing you like this is a library that you can use to have this kind of JSR system. This is also not complete. Like JSR has a lot of stuff that's in there for partitioning, for parallel calls. You have, as I said, replaying things, which is quite useful. Checkpoints, so if a large job failed at some point, you can start it over at that point, which is definitely something you can look into. It's something that is actually quite interesting to actually have this running as part of the Symfony ecosystem, or just PHP ecosystem in general. So it might make sense at some point to look at this, can we do this in a generalized fashion to provide a library? I know of one attempt that actually exists that is basically inspired by Spring Batch, which is kind of the reference implementation that I know for JSR 352, and that is Akeneo has this tool component batch and batch queue library. I'm not sure how good it is. So you can see that last changes is 2 months ago. I think I took the screenshot yesterday or today. So it's not that active, but it's already actively used. And you can actually see in Akineo how well this thing works if you actually in your application want to provide an interface to your whole batch processing and importing systems. If, for example, you don't want your users to give access to Jenkins, you can actually provide a Jenkins-like interface in your application. And it has the same contents. You see the jobs there. You can see the job execution where you pass in the parameter, in this case the file, and then sorry, the job instance, and then the job execution where you can even see the steps it went through to process it. So they Akineo as a PIM, obviously importing and exporting is one of the core things they have in there. So for them, it totally makes sense to have it as well prepared and as well presented as they can. If you look at other systems that even in a Symfony closed ecosystem like Shopware 6, they also have some ideas like this is basically a profile is a job description, but it kind of stops there. Everything underneath is that they have something like specific readers that try to read records in an iterative fashion. But it's not trying to be an explicit JSR kind of thing, and it doesn't provide any useful like user interface for the jobs that are running, which again makes sense for their use case, because for Shopware the whole importing exporting thing is not core of their platform. So why spend too much time investing in actually building a fully built out job running system? All right. So as I mentioned, this is really abstract. I find the idea really neat, and I borrow from this JSR specification and from the Spring Batch documentation often enough that I find it useful to just skim over it and take at least inspiration for kind of jobs I'll use. But I think that just presenting that is not really that useful to you because there's no reference implementation you can use. So I figured what would actually help you is, okay, what can I do to make my jobs better that I already have my batch jobs? So first, let's start at reading. I will concentrate on those things, and actually only 3 of those things. So who here had the problem that they had to read in XML files that were like a few hundred MBs large, and basically their PHP job just crapped itself and didn't work? It happens all the time. And usually it happens because they read in the XML file as a whole thing. And what you can do is you can use a pull parser to basically read that XML file as kind of a stream. And the good thing is that there's a PHP extension that is very easily accessible. You just have to enable it, that provides the XML Reader. And so as an example, this is basically a file that I will read in with an XML Reader. It's just a sitemap definition, and I want the URLs from the sitemap definition, so always the log node. And this is the code that basically does it. First of all, I create a new XML Reader instance. Then I open my sitemap file. And this is basically the part that does the streaming thing, where it only reads in chunks of the file. And with each chunk, I basically check what kind of node type is it? Is it an element, an XML element? And does it have the name log? If so, then I will just read the string, and it basically will give out the URL. Obviously, this is a very naive and simple example. Like if you have proper XML imports to do, this will be way more complicated and hard to debug and everything. But at least it gives you a way to read in the file chunk by chunk instead of just loading the whole thing and just doing XPath and stuff like that on the full file. So it consumes less memory and basically prevents you from having a fatal memory error. Keeping the theme of professional, probably you don't want to echo stuff in your jobs, but yeah, it worked for me, and I have a little example thing that I can show later. I will skip JSON because it's basically the same thing. You have to look for JSON pull parser and read it like bit by bit. And even though CSV, it's kind of the same thing, I still think that CSV imports are the most popular. So I figured that this is something that I should explain how to do the same thing. You can just use fopen and fget CSV and everything. What I personally like is use the SPL file object to have a kind of object-oriented way of streaming stuff. and then use something like fgets or fget-csv to actually get a line from this file. So this is what the code would look like in the example. Originally, I thought I have something that later on that will actually show some real code. But yeah, you open the file object with the file name. It will throw an exception if the file is not there. And then until the end of the file, you just get each line one by one. And this helps you to basically read in the file bit by bit, line by line. And so you don't use up too much memory by having the whole file read into memory, which in an example that I will show you later, it's a 500 MB file that I got. And just keeping that in memory and doing stuff on the in-memory representation will basically kill your PHP process usually. The downside is that probably you have to store this data somewhere, so in an array, for example. So what you end up with is, even if you don't read the whole file, in the very end, you have all this data in your PHP process in an array. And the way around that is generators. This is something that, even though it's not that new, like generators exist since PHP 5, it's something that I sometimes see at conferences, but I rarely see used in code. And I get why. They're really intimidating. You can shoot yourself in the foot with them. They sometimes have quirky behavior. But if you take anything out of this talk, is you totally should look into generators and play around with them, because they actually can be fun. You can use tricky things like one generator feeding another generator, and basically you push data around and have some kind of pipelining system, which is pretty cool. And yeah, so basically this is what it boils down to. We have a CSV-like file that we read in line by line, and instead of creating an array, what we do is we yield. You can even use the key value notation from arrays. So basically what you get back is an index and the actual value. And to be honest, you don't even get that back when you call input parser. What you get back is a generator object, which is kind of an iterator. And then once you for each over it, then you get this data back. And that can be a bit tricky, because every error that's thrown in there is basically just thrown when that loop is called and when it happens. So you might actually see that if that data doesn't exist, if you think back to the file object, then basically only once you run the for each, you actually notice that the file is not there, because before you just got the generator, but the code in there was not actually executed. But as I said, it's a tricky thing, but it's totally worth checking out. And another thing that you basically have when you read in CSVs, besides the whole memory issue, is usually that you get stuff like that, encoding issues. This is one thing why I think people don't like CSVs. And luckily, so now we get to some Symfony stuff. With Symfony 5, the Symfony string component will make it a lot easier to work with this kind of stuff. And basically what it boils down to is that your string has different representations. There's this byte representation, and I will focus on the Hindi, even though I can read it myself. It actually illustrates the issue pretty well, that basically each character that you see and read is actually made up of potentially different byte sizes. So basically you have to map those bytes to a code point table that tells you what each byte represents, and depending on your character set, this will basically have different representations. And on the code point table, you can actually have stuff like this, where two code points will make up one object by basically combining them. And at the very end, you have the grapheme cluster. This is basically what you want to have, your basically Unicode encoded string. And basically, Symfony string provides you an abstraction for all these three layers of a string. You can go on the byte level, and from that byte string, you get a Unicode string by telling it what kind of encoding you want to use, and it will actually throw exceptions when it's not, for example, a UTF-8 compatible string. And the reason why this is useful is you probably have seen this, where people just use MB string length stuff and just throw MB methods around when it's string related, just to be sure it's safe Unicode thing, when they actually don't really know what is happening and what's going around. For example, if you compare a byte string and get the length, this will be considerably longer than this and then this. So this is length 4, this is length 6, and this is length, I don't know. And actually, calling the length method on each of these strings will actually give you the length of your current representation. So you can actually work really well with either the very low byte string data if you want to. Most of the time, you just want to make sure that you create a Unicode string from it that is actually the representation that you want to see and you want to write to your database most of the time. But it actually gives you a convenient way to work with strings and to make sure that you call the right method when you for example, check the length or merge stuff. And this is kind of the summary, what it would then look like if we use it. So we have our SPL file object, we check for the CSV of end of file, and instead of just getting the CSV output and storing an array, we will yield it, so we use generators. And there's a nice convenience method around the byte string called wrap. Basically what it will do is take an array of strings and return a array of byte string objects, and then later on this byte string you can basically move into a Unicode string with your encoding, and then the reading can look something like this. You have the reader itself that will basically give you back the generator, so you don't actually get the data back, and then once you for each over this generator you get back the row, which is our byte string array that we yielded, and then we can process each row and we can write to each row. This is obviously not JSR thing because I'm writing each line by itself. It just had to fit on a single slide. All right, so this is all about the kind of file-based systems for reading those. Another thing that I wanted to cram in there is repository-based reading. So sometimes you want to actually read stuff from a database and write it to something else in an import. And sorry, I jumped a little bit. And what's important there is usually if you have some kind of query for getting stuff, you use get result. And what I used to do for quite a while is I'm smart, I use iterate, so I get an iterable result and I don't get all the data back, which is actually kind of not true. You still get the full result set back from the database. So if you do a select star from and you don't limit yourself, you will actually get all the data back and it will fail. What it will do is basically hydrate once you get an object, and only the hydration is done iterable, but the actual data is already there, at least as far as I know. I hope there are no doctrine people that will shake your head. I don't see any. But yeah, so you have to be careful. If you use doctrine and read stuff, you have to limit yourself. You can't just do cheap tricks or anything to get all the data and then do this. But the good thing is, oftentimes you don't even have to do that. Going through PHP to just read something, for example, from a CSV file and write something to a database is kind of annoying. Oftentimes you can quickly do stuff within MySQL and even import, for example, CSV files in MySQL with float data, local and file, and you can set the encoding, everything. And this is considerably faster than actually reading the CSV file and writing stuff. So just knowing what your database can do and going down to the level, not just for writing the stuff, but also for reading, will actually have a long way to know what you're doing. Okay, writing is pretty quick. I will focus on database only, even though you could think about like writing to, I don't know, Elasticsearch or whatever. And actually the Doctrine ORM has a pretty good documentation about batch processing. And I want to pick out two of the quotes I find most important from there. First of all, an ORM tool is not primarily well suited for mass insert, update, or deletions. So basically, you can use Doctrine ORM to do this stuff and to use bulk processing and importing, but the Doctrine team itself says like yeah, probably not the best choice, maybe fall back to DBALL. And one of the reasons it is a bad choice is you often run into memory problems, and this is the common problem that I see when we write stuff into the database with Doctrine ORM is we have huge object graphs, we never clear the unit of work, so it stays in memory, or if we do, we load stuff again, and that is basically the killer for having a good batch import or batch process in general, that because you have a process that lives long and handles lots of data within the database, it will just use up lots and lots of memory. There's ways around this, especially around caching, for example, like second level cache. So you clear the entity manager often and then just fetch the data again, and it's loaded from the cache instead of the database. So it feels like just doing a query, but it's actually not hitting the database. But it takes a lot of effort to actually do it well. So most of the time, one of the performance improvements that I do is actually I bypass the ORM and go directly to DBAL. In case you can't do that, there's a few things to look out for anyway. So especially during development, something that hits me quite often because I forget is there is an SQL logger running on your DBAL connection that basically logs all the queries you do, and even if you have a very memory efficient batch process, just running this logger in development will basically get you to a point where it won't work anymore. Luckily in Symfony you can easily disable it with app debug 0, so you don't have to write this code, you don't have to disable it by setting it to null. You can just pass in this argument during development, so this is quite helpful. Another thing is that obviously you want to do batch processing. So basically you split up your write processes into smaller batches. I think it's pretty straightforward and common. You just create an object, you persist it at some point, and then once a certain limit is reached, you flush the entity manager, you clear it to make sure that the memory is basically not used up by the stuff that you persisted. This also means that the stuff that you persisted and flushed is not there anymore, so you can't really work with those entities in a follow-up. You have to fetch them again. But again, going back to the introductory stuff with JSR, since you have a step that does one read, one process, one write, and then you have another step, it's actually a good idea to write those steps as if they were independent and actually use find instead of just working on like pushing data around and keeping it alive over multiple steps. It takes a lot of effort and basically you have to do it yourself manually, but it can be done. And the good thing is there's this Ukrainian Doctrine batch utils library that kind of helps you writing these batch process stuff, so you don't always have to write manually. It works on query objects and stuff like that. It's now maintained by Patrick Reimers. And yeah, if you want to do batch processing, not just on the command line in import tools, this is something you should look into. And as I already mentioned, the first thing you should do is basically go back from the DBA ORM to the DBAL layer. You don't have to go to PDO or anything lower than that. DBAL is a fine abstraction. It's very thin, so you can still have a query builder and everything. So don't go overboard and just throw everything out and try to create basically your own super fast, efficient ORM. You won't be able to do it. And yeah, the other thing is use caching in Doctrine a lot. Like use the query cache, result cache. Look into the second level cache. It's fairly new. It will be even more relevant when and if Doctrine 3 comes out at some point, because some methods that we usually tend to use to bend Doctrine our ways will be removed, and then you basically have to do finds more often because merging and detaching, for example, is not allowed anymore. And so you better already start looking at the second level cache. If you actually use the DBAL for writing stuff, one recommendation that I have is that that what always bothered me is now I have to write a command line job or batch job that actually has to look into my database and the table name and the fields and everything, which I have maintained in my entity, and I don't want them anywhere else because I might miss that they change for some reason. So I still want to read this data from the annotation I have on my entities, and you can do that using the entity manager's get class metadata. It basically gives you the table description for that entity class, and you can get the table name, the field names, the ID, and everything. It makes it a little bit harder to read, but for me it feels nicer to have this, to kind of have an abstraction from actually writing the table names and fields yourself and then forgetting it at some point and the job fails because I did a database migration and forgot to change it here. That's all I have to say about write. The most important bit and the thing that basically goes back into what I initially explained with JSR is processing. I won't go too much into basically processing on a step level. I want to look at it more from a bird's eye view, like generally processing batch stuff, and more importantly, the different ways of improving the performance in a batch process by looking at concurrency, running it in parallel, and I already mentioned partitioning. So what is very important in most cases is that when you run your batch job, you basically want to make sure that you only have one instance running, because otherwise they compete in writing and will mess things up. I actually had this in a client project where we basically had an infrastructure with 3 application nodes that were running the web system. And then when we deployed it, Ansible basically said the first node is the one that's going to do our batch processing. And when that node went down, basically we fall back to a different node. But we never really updated which node is now the master responsible for doing the batch things. So from time to time it happens that 2 nodes actually did the same thing at the same time. And it tended to work out that one of them stopped early on, so it didn't bother anyone. But from time to time, we actually had double the orders in our system, which sounds great, but obviously the customer doesn't like to have paid double. And yeah, one way around that is Symphony Lock. Basically, what this does, it guarantees you exclusive access to some shared resource. In this case, if you, for example, have an import that basically reads from a file or writes to a database, you make sure that this is only the one import that is running and you don't have other instances there. And yeah, it ensures that a command is not executed more than once at the same time if you want that. The Symphony Lock has multiple storage engines that it supports. The very basic ones are the flock store and the semaphore store. The flock store is basically a file log, but it doesn't work on all network share stuff like NFS. So with semaphore store, you're safe. The only downside is this is a local thing. So if you have the scenario that I just described with 2 app nodes running, then obviously unless they write on a shared file system or shared directory, then obviously they wouldn't know that a different server runs this process and logged it. So you need a remote storage for the lock. And there Redis or PDO store is fine. By the way, PDO store also works with a Doctrine DBAL connection because it basically wraps PDO. And yeah, so this is what it looks like. You create a lock factory and pass it in the store that you want to use. And with that lock factory, you can then create a lock, which you ask, like, I want to acquire a lock, which basically tells other processes, I'm working now, you should not do anything. The 2 is just setting it to blocking, so it will throw exception when I do something that basically someone else acquired a lock for it. And then I can do stuff, and at the very end, when I'm finished, I will release the lock. By default, the lock is released after a certain amount of time. And just to give you a quick idea of what it will look like, even though I don't have that much time, let me basically show you a quick demo application. So all this does is what you just saw. It will basically start something, it will sleep for 10 seconds, and it acquires a lock. And when I run the second process, you can see that it waits for acquiring a lock because this one already got the lock. And now that this lock is released, you can see that it actually started working. And so basically you can run jobs after another, or you could also set this to fail. But the important thing is you don't have any concurrent access, and that is basically what you want the log for. If you want to have concurrent access, you might want to look also into logging, but on a different level. You want to look at logging on the database level, and luckily Doctrine provides something for us, an optimistic log and a pessimistic log. On batch tools, you probably want to have pessimistic logging, but it's a little bit harder to explain and to show. So I will just give you the quick version of an optimistic log, which you would kind of use in a web application usually. So basically, you provide in your entity an add version constraint annotation for Doctrine, which tells it that this is where the version is stored in. This can be an integer or a datetime, and Doctrine will manage this field for us. We don't have to do anything with it, basically. We just need a getter to get the current log. And then at some point when you do something, you ask, I want the user by ID with optimistic lock mode and for the version that I currently have. So basically, I already have a user acquired at some point. So think about you have a multi-step process in a form that then basically at the very beginning you acquire the lock and you make sure that you can read the stuff. But as soon as you want to flush something, and the version got out of sync, so I asked for version 184 because that is the initial one that I got, and someone else wrote something in there, I will basically get an exception that, sorry, the version that you are working on is not there anymore, there's something newer, and with that exception you can basically react to it by fetching the newer data and basically displaying it, and the user has to then decide how to reconcile the different version constraints. This is basically optimistic locking. The pessimistic locking doesn't require you to do the version thing, but actually using it is a little bit similar. You can also get a lock and it's just lock mode pessimistic. The tricky thing is most of the pessimistic locking, all of the pessimistic locking stuff is done in the database, so you have to work transactionally, otherwise you get exceptions. And basically the pessimistic locking is just that you get exceptions early on if you want to acquire the lock and someone else has it. Really look into it if you have concurrency in your batch processes and you basically want multiple processes working on the same amount of data, and you have to make sure that they basically don't write garbage data because they run in different order. I will skip parallel for now and just jump into partitioning. Also, I don't have that much time, so I will do it very quickly. Basically, it means that you do the same thing, but you do it multiple times and with different chunks. I usually do it in a very, very naive and trivial way with processes. And I actually have an example there that I can show you later. And basically, you have a code that reads, in this case, a TSV, which is like a CSV just with tabs. And this is basically reading how many lines there are, the initial thing. And that basically tells me how many partitions I need because I know how much data I have. And then what I do is for all these lines, I will collect some processes. So I set a limit how many processes I want to run. Check continually if a process is running. I don't want to start a new job. I just sleep for a few seconds. And this is basically the code that actually starts my process. This is the Symfony process component. It starts a completely new PHP process. I specify at which offset I want to import and how many lines I want to read. And then it starts this process, it runs in the background, and as soon as one of those processes finishes with its chunk, then basically a new one gets spawned. How it will look like is basically like this. So this is an import I did with 9 million lines with just plain reading it, and every dot is 250 items batch that is being stored. And it took 1 hour and 3 minutes, and this is basically the trivial partition thing. I will zoom in a little bit. So, I'm so sorry. Where's the presentation? I have to jump out of the presentation. So this is the initial thing. As I said, each dot is basically a batch of 250 items that I wrote. This is all the stuff with the generator and clearing the entity manager and everything. So it's memory efficient. It just used up 13 MB, but it still takes 1 hour to process 9 million something lines. And the partitioning is doing exactly the same stuff, but I split it up into different processes. And you can see I started my 5 processes, I waited, then they finished. And at some point, it's maybe one process is faster or smaller, slower. And you can see it stretching out where it's just starting one process instead of all 5 processes new. The important bit is this, that even though I did the same thing, I still used up only 10 MB, which is kind of cheating because I only look at my master process, not at sub-processes. But it just did it in 28 minutes, so less than half the time that I had before, just by splitting up in smaller processes. The downside, this approach is very simple, and I originally wanted to show the code because it's the same code that I had initially. I just added the amount and the offset thing, and then added a new job operator thing on top of it, basically, that managed the processes. And so I don't have to look into the code into detail. I can just speed it up by making sure that it works in smaller chunks. It doesn't work with every process, but it's kind of cool. The downside is I can't look into those processes. I can't see when it fails or anything. So it's still kind of iffy. So let me just give you the final thing, because I think I already run out of time. One thing that makes it even better to have this stuff is the Symphony Messenger. You can basically create job queuing. For example, in your database, it creates a Messenger messages table. It stores all your messages, which is basically your batches, and then you can just have a handler that runs these batches one at a time. And in terms of JSR, this is basically remote chunking that you have. And I will stop it there. And if you're interested in more details and some code samples, just come up to me later. Thank you all.